Hi, this is Janie Helms, and for my peripheral nervous system presentation, I'm going to be focusing on the different types of eye vision, how the eye is set up, and what causes, and how to correct the types of visions if they are incorrect. So the objectives of this is talking about the three types of eyes. You have the normal eye, meaning everything is functioning properly, nearsightedness, and farsightedness, and again, how we can correct issues for each kind of person. First, let's talk about the actual structure of our eye. So our eyeball, usually it has a circular, regular shape. It's made up of two specific parts that's going to help on how light is refracted. Now, light waves, when they hit a surface, they are refracted a certain way. A lot of the times, you can see this through, if I have the sun and its rays come down, and when it hits the water or any kind of surface, depending on the type of surface and how fast or warm or cold that surface is, those light waves bend when they get into that other surface. As it passes through, it changes the direction, which can make an object seem weird or different than what it truly is. A lot of the times with water, you see it where a fish looks closer to you than normal, or if you're swimming in a swimming pool and you're trying to dive for, the diving toys, they're not always quite where you think they're supposed to be. So our lens and our cornea, they kind of work the same way. So their refractive ability, how that light moves through our lens and gets to the back of our eye where the retina is and where it can send that message to our brain, all of that is going to depend on how strong the lens is and how it is controlled by the ciliary muscle. Now, in this picture, I have a picture of the eyeball. I have a picture of the ciliary muscle. And what it is a smooth circular ring attached to the lens with these ligaments. The green part right here, these are the ligaments. And what happens is, if you think of a stress ball, when a stress ball is not being squeezed, it has a perfect round shape, and that means all of these things in here, those ligaments will be stretched tight where they're supposed to be. And when they're stretched tight, that actually causes this lens to flatten, which could make for a weaker situation. But then think about when you squeeze a stress ball. You squeeze it and everything inside gets squished closer together. So imagine that if the ciliary muscle contracted, and that's going to cause these ligaments to become looser. They're going to be more squished together and not stretched out. This causes our lens to be rounder and normally stronger. Okay, now since we said that the lens and the light refraction is a big deal about our image, we kind of need to talk about different types of surfaces and how it causes light to refract. So when light refracts, I can have two types of surfaces. I can have a round pointing outwards towards that light source, but then it could also bow inward. Okay, so I'm actually going to talk about the bowing inward first. This is called a concave lens. Actually, let's take away that part. So concave, meaning like it caves inward. When those sun rays enter in here, they're actually going to spread out. So if you think about this rounded edge here, it's going to come through, but when it gets this angle right here, it spreads it out. It redirects it because of that angle and that bend. So it actually diverges or spreads those light waves out. With a convex surface, it bows outwards. So when the light hits it, it's going to redirect it actually to a focal point. It's going to bring these rays together. So, and this is what we really need. We need these things to come together. If they meet at the back of the retina, everything will function properly how they're supposed to. So in a normal eye, which a normal eye is called Hyperopia, the ciliary muscle is going to relax and contract whenever it is necessary. If you need and use your far vision, it's going to relax. It's going to cause those ligaments to stiffen up, that flatten, and the way those light waves refract in there is exactly what you need to be able to see. Now, to be able to see close up, that's when it's going to contract. It's going to contract itself, loosen those ligaments so that the nearsightedness or the near vision can work properly. So if your eye is normal and it does what it's supposed to, the ciliary muscle goes in and out, and it is controlled by the autonomic nervous system. Now, unfortunately, many people do not get the wonderful experience of a normal eye. I am someone who experiences nearsightedness. I am almost legally blind, and it is because I have an elongated eyeball. My eye is too long, and so normally my lens, it causes it to be too strong, and it can't contract and relax when it should. So if you look in this picture, someone who is nearsightedness or suffers from myopia, the eyeball is too long, so instead of the focal point meeting at the back of the retina where it should, it meets its focal point too soon in front of the retina, which causes your retina and that message to your brain, it is going to be a blurry image because it hasn't reached your retina to give a clear view, a clear image to your brain. So the way that we can correct that is glasses. If you wear glasses, or the way that your contacts work, they are going to have a concave type of form. And so what that's going to do is it allows for those rays to extend or spread outwards more than what they would have hitting your normal eye or your original eye. And when they spread outwards, that focal point allows it to happen further back in your eye. So again, here, they're a little closer together, so they meet too soon. But using the concave lens, it spreads it out. So just make sure you see this. These right here hitting your lens are further spread out than when it hit here. So since they are further spread out, they're able to meet with the focal point back here on your retina where it should be. Here, the focal point met too soon because they weren't as spread out. So the concave lens corrects the elongated eyeballs issue. Sorry, go back. Okay, now if someone suffers from farsightedness, we say that they're hyperopia, meaning that they can't see close up. They have issues with their ciliary muscle contracting and loosening when it needs to again. But this had the long eyeball. This person, in that case, theirs is too short. So when the light hits, they are going to cause where they don't meet at a focal point until past the retina. So it's not a clear view at the retina where it needs to hit. So what they use is this convex lens, which causes it to angle inward more. So when it hits the eye, they are closer together, bringing the focal point to the back of the retina where it should hit. So here are my references. I used our book, and with the image with the eyeball here where it showed the ciliary muscle, it talked about the shape of the eye, the muscle, the ligaments. This image I got from our textbook, and these were from a vision correction right here. It was a CK12 education website where it was talking about the shape of the eye and the different types of eyes. So again, going back to the objective here, normal eye, your eye is the correct shape, your ciliary muscle works how it should with contracting and relaxing when it should. If you're called nearsightedness, that means you can't see far away. Okay, you can only see near you, close up. Farsightedness, it's the opposite. You can see close up. With farsightedness, you can see far away, you can't see close up. So thank goodness for our understanding of our lenses and how concave and convex surfaces can help us out. Thank you for listening to my presentation.